This is a video-only screencast I made. I'm not sure what happened, but anyway, so I'm gonna just watch it and talk, and I don't know if this technology is gonna be effective, but if it works okay, then it'll be great. If not, that's why I named this. Oh, you can't see it anymore. Oh, here it is. File name. Oh, I'll expand this, and then I can do this. This is the file name, Chapter 3 time sync, because I'm figuring this is going to be a big waste of time. If you're watching it, I guess it wasn't. Functions are pervasive in Rust code. You've already seen one of the most important functions in the language, the main function, which is the entry point for many programs. You've also seen the fn keyword, which allows you to declare new functions. Rust uses snake case as the conventional style for function and variable names. In snake case, all letters are lowercase. Oh, stuff is happening. How far off the screen can I put this? Yeah, if I can see that jiggling right there, I'm happy. No, okay, it's time. It's time to move it. Here we go. What else I got going? Oh, hey, that's not actually... All right, hold on. Whoa. This, and then go in here. There we are. And then you can go to... And now I want this. Yes, okay. So an empty one. I'll put it back there. Okay, so this will go here. And then... I guess I'm gonna monocle. Yep. Then we don't need two of those. Who knows what I said? Oh, look. Hey, my cursor was here. Where was I? Okay, here's a snake case. All letters are lowercase and underscores separate words. Here's a program that contains an example function definition. So we've got the print line macro prints hello world, and then another function, and here's another function, print line, another function. And so I have, yes, okay, of course I changed things. Function definitions in Rust start with fn and have a set of parentheses after the function name. The curly brackets tell the compiler where the function body begins and ends. We can call any function we've defined by entering its name followed by a set of parentheses. Because another function is defined in the program, it can be called from inside the main function. Note that we defined another function after the main function in the source code. We could have defined it before as well. Rust doesn't care where you define your functions, only that they're defined somewhere. Let's start a new binary project named functions to explore functions further. Place another function example in source mainers and run it. Yes. The lines, I'll read what I can see, and then I guess we'll just talk a little bit. The lines execute in the order in which they appear in the main function. First, the hello world message prints, and then another function is called and its message is printed. Function parameters. Functions can also be defined to have parameters, which are special variables that are part of a function's signature. When a function has parameters, you can provide it with concrete values for those parameters. Technically, the concrete values are called arguments, but in casual conversation, people tend to use the words parameter and argument interchangeably for either the variables in a function's definition or the concrete values passed in when you call a function. The following rewritten version of another function shows what parameters look like in Rust. So we've got in main another hey there, another function is taking 5 as an argument, and 5 is an I32. I mean, I guess if it qualifies as an I32, we don't have to say it is one, right? Because the function parameter says, give me an I32. I'm going to call it x. That's what this says. Function parameter says, let x equal an I32 that you're going to give me. Except I don't have to put all the let in here. It took me a little while. I was confused by that just a bit. So yeah, this x is instantiating a variable, right? And the reason it does that is because it's going to need it down here, and we'll need to be able to refer to the argument. So what do I have down here? Another println again. What am I looking at? It's in the way. Something times. What is this? This little thing? Oh yeah. So you see how this font is Fira Code, which is Mozilla's Fira Mono with hey, whoa, what's going on here? Again, 42 times. Yes. Oh, this is distracting. Back to the text. The declaration of another function has one parameter named x. The type of x is specified as I32. When 5 or 42 is passed to another function, the println macro puts 5 where the pair of curly brackets were in the format string. You just took away my... What in the world is going on? Okay, I'm looking for a... What is this? I'm looking for a key sim... Bracelet. Oh, brace. Yeah, there it is. Right there. Bracelet. Okay. I know, man. I was getting on my soapbox here. Well, it's gone now. I saw it. It was there. Okay, should I back up the video? This is so dumb. Why am I doing this? Okay, so hold on. I might as well talk about what's happening. So this is a utility XEV, which will do this. So this opens a window, and then I don't know if it's like X11 event. I don't know what the V is for. Event tester. Yeah. That okay. Well, should have called it XET. No, XEV X event. Yes. So what I'm looking at here is, what do you call the thing that everyone keeps calling a curly bracket and aha, right, oop. Oh, that was fast. Here it is. So keysim that brace left. Brace. It's called a brace. So I was getting fussy in this video about how everyone calls them curly brackets, but they're really called braces. So we're gonna, guess, just wait for me to be done with this. I got double standards. I'll back up. I will back up in a without a second thought if there's something I want to see. But this is only a 20-minute video, so I mean, it's not gonna be because I've been pausing it. Alright, so where was I here? Where was I? Well, wait a minute now. Hold on. So the println macro puts 5 where the pair of curly brackets were, and I just went through a whole... I was proving that they're really called braces. Well, they are what you call them. in function signatures, you must declare the type of each parameter here. This is a deliberate decision in Rust's design. Requiring type annotations and function definitions means the compiler almost never needs you to use them elsewhere in the code to figure out what you mean, like there, for instance. When you want a function to have multiple parameters, separate the parameter declarations with commas, like this. I guess we're going to go back and add that. So we've got this example creates a function with 2 parameters, both of which are I32 types. The function then prints the values in both of its parameters. Wow, did I really not read that yet in the video? Yeah, I've been over that, dude. Brackets were in the format string. What if I try to read what I'm pointing at? Oh, and then I stop pointing. Wow, this is either the most boring thing you've ever watched, or the new hotness. Video format, where I try to chase my cursor from a video without audio. Hey, there we go. So I'm going to put in another parameter. No, don't you copy and paste that. No, he's not. That's not what I'm doing. I don't do that. He was highlighting it. Just highlighting it. This is this font is called Firacode. It's Mozilla's Firamano with ligatures, which I don't see any on the screen right now, but I suppose they'll show up. Ligature is like when you have 2 symbols that you see combined a lot, or you see them adjacent a lot, like those 2 characters make one symbol, like one logical unit, and so then a ligature will be a special glyph that is triggered when it has these 2 characters side by side. This must have been before I figured out how to use the terminal inside of code. I was having some trouble with it. I think I was trying to use a now I'm just using the native terminal in code. Do I need to read more? Yeah, okay, so function parameters don't have to be the same type. They just happen to be in this example. So you run the code, and then we get it. We get the variables printed, the values printed. Wow, this is hard to do. Maybe I should close my eyes and talk. Smash that like button if you want me to do this again. Okay, function bodies contain statements and expressions. Function bodies are made up of a series of statements. Oh, I shouldn't pause it. That's a bad idea. Okay, I'm putting the mouse down. Function bodies are made up of a series of statements optionally ending in an expression. So far, we've only covered functions without an ending expression, but you've seen an expression as part of a statement. Because Rust is an expression-based language, this is an important distinction to understand. Other languages, don't you move it. Sorry. Other languages don't have the same distinctions. So let's look at what statements and expressions are and how their differences affect the bodies of functions. We've actually already used statements and expressions. Statements are instructions that perform some action and do not return a value. Expressions evaluate to a resulting value. So some examples. So if you use the let keyword to create a variable and assign it a value, then that's a statement. So it ends with a semicolon. Statements don't return values. Therefore, you can't assign a let statement to another variable, as the following code tries to do, you'll get an error where let x equals, and then in parentheses we have let y equal 6. When you run this program, the error you get tells you that it expected an expression and it found a statement. So yeah, let is a statement. Let it be. The let y equal 6 statement does not return a value, so there isn't anything for x to bind to. This is different than from what happens in other languages that I don't know about, such as C and Ruby, where the assignment returns the value of the assignment. In those languages, you can write x equal y equal 6 and have both x and y have the value 6. That is not the case in Rust. Expressions evaluate to something and make up most of the rest of the code that you'll write in Rust. Consider a simple math operation such as 5 plus 6, which is an expression that evaluates to the value 11. Expressions can be part of statements. In listing 3.1, the 6 in the statement let y equal 6 is an expression that evaluates to the value 6. Calling a function is an expression. Calling a macro is an expression. The block that we use to create new scopes is an expression. For example, here in our main function we have let x equal 5. Then let x equal, and we open some braces, and let's say inside of it we have let x equal 3 statement, and then x plus 1, which is an expression. Interesting, because it returns a value, a result. So this expression, so the whole thing is an expression, even though, okay, so this expression is a block that in this case evaluates to 4. That value gets bound to y as part of the let statement. Note the x plus 1 line without a semicolon at the end, which is unlike most of the lines you've seen so far. Expressions, he's about to click on that. Don't you click on it. Expressions do not include ending semicolons. If you add a semicolon to the end of an expression, you turn it into a statement, which will then not return a value. Keep this in mind as you explore keep it in mind. Functions with return values. Functions can return values to the code that calls them. We don't name return values, but we do declare their type after an arrow. In Rust, the return value of the function is synonymous with the value of the final expression in the block of the body of a function. You can return early from a function by using the return keyword and specifying a value, but most functions return the last expression implicitly. Here's an example of a function that returns a value. We have the function 5, returns an I32, and then there's just this one expression, 5. And that's fine because 5 can be an I32. Why not? So we put in the main function let x equal, and then on the right side of the copula is our function. We call the function 5. Then we got a println. The value of x is a scope. Is that a scope block? Is that what we call that? I'm searching for the word. Oh, hey, look, a ligature. Okay, so right here we've got an arrow, and then over here it becomes a ligature. If you watched while I was typing it, first I typed, this glyph, and then when I typed that, it combined. In my videos since this one, I've been using a variant of Fira code that I am working on because I really like Fira code a lot. One of the reasons I love it so much is the G right here. I just really like that G. And sometimes you can find fonts that have that kind of loopy G and it looks really good, but then the A is kind of not so good. Like there's one font I like a lot. Well, there's Lato, Lato, and then there's a serif version called Aleo or Aleo or something. And I really like Aleo, but the A glyph in Aleo, the bottom of the A, where's an A? Macros. See how this bottom of the A is pretty well rounded? It is not like that in Aleo. But Aleo is not monospace anyway. I bet I could take any old font I wanted and convert it to a monospace font. So what I was looking for in... What have I done? Again, 41 times. Again, 1 time. Let x equal 5. 5a, wait. Here, 5, 2. Why did I do this? Oh, a storm is a-brewing. I hope the power doesn't go out. But if it does, I'm using a laptop. Oh, back to the reading. Oh no, what did I miss? The power just went out. Unbelievable. Did it? Hold on. Oh, no, it didn't. And sorry, I just kicked my computer. That's what that was. Yeah. So, well, I'm enjoying this. I probably won't enjoy watching it or listening to it, but I'm having fun. Did I miss anything? Do I have to talk about this? I mean, I suppose if reading the book was a good way for you to learn, you'd probably just go read the book instead of watching my video. Alright, so second, the 5 function has no parameters and defines the type of the return value, but the body of the function is a lonely 5 with no semicolon. It's an expression, we'll just return it. So now we have let x equal +1, and we give it a 5. Print line, the value of x is scope. I'm just going to call that scope until I have a reason not to. So function +1 takes x and I32 and then goes x plus 1. Are they really using the same variable name? Doesn't the x in the parameter create a new variable? The function's return type is specified too as I32. Okay. Right. But here, this creates a variable. But we've already created a variable called x. But I guess because x isn't in the scope, because this scope comes out of the +1 function. Yeah, so we plop a 5 in, we'll call this x now, right? And x plus 1, and when it comes out, then it gets called x over here. Well, they could have used different variable names. Running this code will print the value of x is 6. Put a semicolon at the end of the line containing x plus 1. Changing it from an expression to a statement will get an error. Help. Note. Expected I32 found some parentheses. Empty tuple. Is that what this is called? Right here. An empty tuple. So mismatched types, the core issue is that the function plus 1 says it's going to return the I32, but since we added the semicolon, we have a statement that doesn't evaluate to a value. So that is expressed by statements don't evaluate to a value, which is expressed by parentheses and empty tuple. I've been wondering what to call things here and there. So we've got this, an empty tuple. It's called an empty tuple. Therefore, nothing is returned, which contradicts the function definition, results in an error. In this output, Rust provides a message to possibly help rectify the issue. It suggests removing the semicolon, which would fix the error. So what am I doing now? I went over there and what time is it? FNPL plus function plus 5, right? Let's see, I don't have a so I'm using DWM. Is this mine? Am I out of the, no, I just paused it, right? Yeah. Okay, so let me jump out. Oh, I don't need that. I must have told it. I did. This is like a, play MPV, play everything in the directory, and then ampersand, exclamation point, and Z shell, ZSH. And I don't know if this is POSIX or bash or compliant, POSIX compliant or like bash or not, but that's how ZSH. One of the ways ZSH lets you function plus 5. Yeah, and so coming in, I'm calling my I32 pickle. And then we'll say pickle plus 1, and it puts out an I31, where I'm going to say let pickle. Yeah, see, I didn't have to call that pickle. That's why I don't think they should have called it X in the first place. In the example, at this point I'm naming it pickle like I think it needs to be called pickle. It doesn't. It's going to be a new variable. But they called it X and then called it X, so I guess I can call it pickles too. Oh man, you know what I should have done? I should have called this Rick. Cargo run. Oh, I'm looking for an error. Here comes my error. I do think that said cargo run, so I'm not sure why I cleared it. Sure. Yeah. Looking for Looking for a pickle. But expected type I32, found type empty tuple. It's funny because people consistently say tuple, a tuple, right? Which sounds kind of silly. So I'll say tuple because I do what I want. But then when it comes to enumerations, they call them enums. Like they don't know that it comes from enumeration. But they do know, so they should say enum. I'm just kidding, say what you want. I will say enum. I will say tuple. I will call things pickles. I won't do this if I'm going to actually distribute something. But while I'm learning, have a pickle. How much more of this is left? Oh, this really went for like 26 minutes? I thought it was 19 minutes. Okay. So the other font that I'm using in the other videos, I don't really know how to work with fonts. What I want to do is create a ligature for the empty tuple right here, right? A ligature for 2 parens where together they just make a circle, because I've seen that in other fonts. Maybe not a ligature that actually produces... Oh, this is another video. Okay, I'll stop here. Am I still recording? Let's see. I am. But it could have been a whole waste of time. It wasn't, guys. It wasn't a waste of time. If it was, you wouldn't be watching it, because I wouldn't have posted it.